Hello, today I will examine the EU aim to be climate neutral by 2050. They want an economy with net zero greenhouse gas emissions in the year 2050. I want to see whether that's possible, and if it is possible, what needs to be done so that it is possible. So let's start with energy consumption today, and how much energy consumption will there be in 2050. I will try to estimate that. Okay, so let's start. As you can see here, we have energy consumption per capita from 1971 to 2014. As you can see, more or less this is linear growth. So in order to get the average growth per year, we just need to subtract these two numbers and divide it by how many years there are. So from 1971 to 2014, that's 43 years. So we subtract these two numbers and divide it by 43, and then we get the average increase in consumption per capita for 1 year period. So let's do that. So we have minus and this divided by 43. So this is the increase from 1971 to 2014. This is the total increase in energy per capita, but we want average in 1 year. So 43, and this is how much the energy increased on average per year. Okay, now we will estimate how much there is energy today, how much energy per capita we use today. Why? Because we don't have the information for today. The last information is for 2014. I'm using World Bank data, but they don't have any newer information. So all that we need to do is to add this number from 2014 and add our average increase. So we have this is average increase per 1 year. So from 2014 to 2021, that's 7 years. So we just multiply this number by 7. Multiply this number by 7, and we get increase to today. This number again is from 2014. And this is the expected energy consumption per capita today. Okay. Now the other thing is we want the energy consumption per capita in 2050. Okay, we are doing the same calculation, except there is one difference, because we want from 2014 to 2050, so that will be 36 years. So instead of multiplying by 7, we are multiplying by 36. So this is the everything else is exactly the same, and this is 36. So this is energy consumption per capita in 2050. At least that's our estimation. So okay, let's do exactly the same thing for population. In the population, as you can see, why do we need population? Because we have energy consumption per capita. So we want total energy consumption, then that means that we have to multiply this by population, by the number of people. So we have the population graph. As you can see, it's clearly linear. So we are doing the same thing. We can see, for instance, how much it increased in the last 20 years, for instance, from 2020 to 2000. We'll subtract these two numbers, so that's this. We will subtract this, and then we will get the average increase per year. Then when we divide by 20, since this is a period of 20 years, and this is average increase, this is per year. Okay, so the first thing that we need to do is that we can calculate the population for today, for 2021. So we will add population in the last year, and this is estimated population in 2021. Estimated population in 2050, however, is we can calculate that as well. This is the population in 2020. This is the average increase per 1 year. So we just need to multiply this number by 30. Okay. So we have here this is the expected number of people in 2050. And now we can calculate how much more energy we will consume in 2050 than we are consuming now. So the energy that we are consuming in 2050 is the number of people times energy consumption per capita. So let's see where is the energy consumption per capita. That's this. This is energy consumption per capita in 2050. And this is how much energy we'll use in 2050. And the measurement units don't matter because they will cancel out. Now we want to divide this number by the energy that we use today in 2021. So we have the population, the number of people in 2021. It's this times the energy per capita that we use today in 2021. That's this. So this is the energy that we use today. Now we will see how much has the energy increased, how much more energy we will use in 2050 than we use today. Okay, so 56%. So if our estimates are correct, in 2050 we will use 56% more energy than we use today. So that's the first calculation that we need to see. And now we will calculate what will happen if we make all electricity carbon free. So what will happen, for instance, if we, according to the plan of EU, European Union, Germany and such countries, Germany is probably the leader in this whole project. So we will see what will happen if all electricity is produced by solar, wind, nuclear, hydro and so on. So first, what we need to calculate now is how much electricity we are producing today. It doesn't matter whether it's clean today or not. I just want to see first the share of electricity in total energy consumption today. And we will calculate it this way. Electricity consumption, we have here electricity consumption per capita. I will scroll here, so this is electricity consumption per capita, and we have energy consumption per capita. The only problem here is, if you have noticed already, we here have different measurement units, and now it does matter. They will not cancel out. So we will have to transform these kilograms of oil to kilowatt hours. How will we do that? Well, I just googled it, and as you can see here, 1 kilogram of oil equivalent is equal to 11.63 kilowatt hour. So we will now write this number in terms of kilowatt hours. So let's see. we will so we times so okay, so we got this number. This is how this is how much energy we are using per capita is expressed in kilowatt hours, and this is how much electric energy we are using per capita. So we are going to see how much of electric energy goes into the total energy that we are using. This is around 14%. So 14% of our total energy consumption is in the form of electricity. So what happens if we completely decarbonized the grid and had carbon-free electricity? So if we do that by 2050, we will have, let's go to okay, so we will have this number is how much energy consumption increased. This is 14%, so this is how much electricity will be there. Just a second. Okay, so this is how much of electricity, how much of energy consumption in 2050 will come from low carbon or zero carbon sources. Let's assume there are zero carbon sources. Let's be optimistic. So now we will see how much it doesn't go from zero carbon sources. So we have 33% increase in energy which doesn't come from zero carbon sources, which comes from fossil fuels. Let's see how much this is increase in terms of dirty energy. So we have, because you need to remember that even today we are producing some low carbon energy. This is even more than 33%. This is 33% increase in all energy use. 33% of total energy use today. That's what this number is. So we will in 2050 will produce 33% more energy from fossil fuels, and this 33% is from the total energy that we are using today. But let's see just how much this is increased if you want a percentage from fossil fuels today. Okay, this is what we want to calculate now. But in order to calculate that, first we need to see how much green energy or how much low carbon energy we produce today. We also have the World Bank data. This is nuclear. This is renewable excluding hydroelectric. And this is hydroelectric source. So let's see. Hydroelectric source is represented around 16%, and I will assume that hydroelectric sources won't really rise because we built hydro stations everywhere we could. So this I will not assume the increase here. So we have 16% of today's electricity in hydropower, and we will need to calculate how much we have green production today in 2021. I will show you how to calculate. We will add this and add nuclear. But first what we need to do is, this is task, this is our first task here, is to calculate how much renewable energy we are producing in 2021. I don't have the data for that. On the World Bank site we only have to 2015. Here we have exponential growth. So this is not linear growth, as you can see, this is exponential clearly exponential. So what we are going to do is we are going to calculate the average growth rate per year. So we are going to say, let's maybe in the last, I don't know, 10 years, the average growth rate. How do we do that? We divide this number by this number. So this is how much, this is the growth rate from 2005 to 2015. I'll show you here. So we have the energy. This is green energy 2015 divided by green energy production. This is all in 2005. This will get the factor, how much it increased over the course of 10 years. If we want to get the average factor for 1 year, we need to raise it to the power of 1/10. Why? Because I will explain you in a moment. Because what does average factor mean? Average factor means that if that average factor happened all the time, it would produce the same result as what's happened in reality. So if you had green energy production in 2005 times the average factor is equal to green production in 2006. So green energy production in 2006 times the average factor is equal to energy production in 2007. That's just what the average means. So as you can see, we will get that green energy production in 2005 times average factor to the power of 10 is equal to energy production in 2015. Or in other words, average factor is equal to energy production, green energy, this is all green, in 2015 divided by green energy production 2005, and that to the power of 1/10. Okay, so this is how do we calculate the average factor. And then when we get the average factor, we can calculate the how much there is green energy today. So we will just have green energy today 2021 is equal to green energy 2015 plus, it's plus, times average factor to the power of how many years? From 2021 to 2015, that's 6 years. So to the factor of 6. That's what we will do. Okay, so now we have, let's calculate that. So this number divided by this number here. Okay. Divided by this number. So this is how much increased. 4.6 times the green energy production increased from 2005 to 2015. So average in 1 year increase was an increase of, let's see, 1.16, so 16% per year. Okay, so now again this is the average factor. Now we need to average factor to the 6th power times the green energy consumption in 2015. So we can put a 6 here to the 6th power and then times the green energy consumption in 2015, which is this. And this is how much energy consumption there will be. Just so I forgot to put a comma somewhere. Yeah. I forgot to put a comma here. Okay. But this is in kilowatt hours. Okay. I wanted to have it as a percentage of total, so I calculated in kilowatt hours, but I wanted to have really this. It doesn't matter. Let's do the same calculation, but no. Let's this here. I didn't want in absolute numbers in kilowatt hours. I want it as a percentage of total electricity production. So this. Okay, exactly the same calculation, nothing new here. So we are dividing this number by this. And this is the increase, so it increased 3.5 times roughly. So the increase in green energy as a percentage in of all electricity produced, it increased 3.5 times. So in a period of 10 years. So let's see how much is that in a period of 1 year. A period of 1 year, this is the average factor. Again, that's exactly the same calculation. You can just put 6 here and times this number here. Okay, this is the estimated, this is our estimation of how much green energy sources are represented in the production of electricity today. It's 14% roughly. Now we will add hydroelectric sources. This is 16% hydroelectric. Let's just create a new tab. So we have hydroelectric resources. 16.2. I'm sorry for that. I don't know why I clicked paste, and I'm sorry for my English because it's very bad, as you can see. Then 14% from grain, and then nuclear. How much is nuclear? Well, nuclear is falling, but we will be optimistic and say that it's still at 10%, so this is very optimistic. And I don't know the percentage today. So we got that the total that 40% of electricity production is done by low carbon sources. So we have that. We also know that electricity represents 14% of total energy consumption. So we have 40% of 14% is equal to 5.6. So 5.6% of total energy, of all energy today, is from low carbon sources. So we have that number here now, which means that 94.4, roughly 94.4 is of today's energy is from high carbon sources. So why we needed this? Because we needed to calculate the absolute increase in the number in the fossil fuels. So today fossil fuels are 94.4%, and in 2050 it will be 133%. So we will divide this number. This is the how much fossil fuels will increase. I need a new tab. I can't get a new tab in a normal way for some reason. My computer is begging. So this is the minus we need to subtract the already producing green energy or low carbon energy, which represents 5 point this. Sorry, this is 0.05. So this is how much fossil fuels will be then, and we need to compare because we need to compare this with now. So in 2050, 127% of today's total energy will be from fossil fuels, but we want to increase in percentages in fossil fuels. So we today have a production of 94.4%, so we need to have this number divided by 0.944. So yes, in the end we get that the increase in fossil fuel production, in fossil fuel energy use, is 35%. So I assumed that all electricity will be produced in a carbon-free manner. However, if the energy consumption keeps growing in the same manner that it has been growing for decades, by 2050 we will have 35% more CO2 in the atmosphere. We will be emitting 35% more CO2 in the atmosphere than we emit today, even if all electricity is produced carbon free, because the energy consumption is growing. The only way to offset the growth in energy consumption is if not only electricity is decarbonized, or however, if electricity is produced without CO2 emissions, but if electricity also represents the much bigger share of total energy consumption, which is what I want to calculate immediately. So how much electricity needs to represent in the total energy consumption in 2050, just so that it offsets the rise in fossil fuels. So as you can see here. So before calculating this, we immediately had this number here. This number here, 1.33. What was that? Sorry, 1.33 minus the green energy consumption. I'm sorry, my brain is lagging, my brain is not working very well. I have a fever, I am not feeling well. The increase in energy consumption here, we calculated to be 55%. Let's find that tab. Yeah, I can find the tab, but we calculated it in the beginning of the video. So increase in energy consumption will be 55% of today's total energy use. So in order to emit the same amount of CO2 in 2050 that we emit today, we need to offset this 55% increase of today's energy consumption. So we need to produce 55% of today's energy consumption in green energy in the next 30 years. In the next 30 years, in order to do that. So let's see again how much we need to build. First of all, here we calculated that this 40.2 is the percentage of low carbon energy while we are producing electricity. However, since we are not going to produce more hydropower, we are only counting nuclear, solar and wind. So we are going to subtract from 14.2%, we are going to subtract the hydroelectric. Where is hydroelectric? It is here, 16%. And this is the 24% of today's electricity is produced from wind, solar and nuclear. But again, since electricity only represents 14% of total energy consumption, we need to multiply this number by 0.14. So 3.3 3.4% of total energy consumption today is produced by solar, wind and nuclear. In order to just emit the same amount of CO2 in 2050 that we emit today, we need to we need to produce 50% of current, 55% of current total energy consumption. So let's see how many times more than we do today. So this is I need a new tab. And this is 55. This is 55% divided by this. So we get that we need to produce 16 times more solar, wind and nuclear than we produce today in the next 30 years. So in the next 30 years we need to produce 16 times 4 amount of solar panels, wind turbines, nuclear power plants, just so that we can offset the increase in energy consumption. That's how much we need to produce. So roughly every 2 years we need to produce as much solar panels, wind turbines and nuclear power plants that we have ever produced. And if we manage to do that, again we will be emitting the same amount of CO2 in the atmosphere in 2050 that we are emitting today. So that's what we are up to. And another important thing is that if we manage to produce 55% of today's electricity in 2050, we need to create infrastructure for that. Because again, in that case, we are already producing 14% of electricity, and if we increase the electricity production by this number, so I need a new tab. So we have the increase in energy consumption, which we will offset by producing green energy. This is how more green energy we will produce, and we will produce all of this in the form of electricity, because that's the only way to do it. But here we are already producing 14% of today's energy in the form of electricity. However, we are not all of this electricity is produced produced carbon free. So as you can see, we calculated this earlier. 42%, or no, just see, now we need this. Yes, so 5.62% is green energy. So 14 minus this is amount of electricity that we are producing with fossil fuels. So we will replace by producing more green energy, we will replace electricity produced by fossil fuels with electricity produced by green energy. So we will minus again, because we are already producing this electricity with fossil fuels, but we are just replacing fossil fuel produced electricity with green electricity. So this is how much electricity, so 61% of current energy consumption will be in the form of electricity in 2050. Again, this is all just to have the same CO2 emissions in 2050 that we have today. So 61% of our current total energy consumption has to be in the form of electricity. How much will be that as a percentage of that in the future? How of percentage of total energy consumption in 2050? We just need to do this. So around 40%. So 40% of total energy consumption in 2050 has to be in the form of electricity in order to have the same amount of CO2 that we have today. All of this electricity, all of this 40% of total energy consumption needs to be in the in the low carbon green sources. Again, that means that we are going to have to build 16 times more solar panels, wind turbines, nuclear power plants that we have today. So we need, in the next 30 years, we need to build 16 times more than we have today. So roughly every 2 years we need to build as much solar, wind and nuclear power that we have today, every 2 years. And when we do that, all of that, again, along with a tremendous infrastructure to support 40% of total energy production being in the form of electricity, which means electrifying a lot of things, maybe having cars which run on electricity and things like that. And if we do, and this is really a hard task, but if we somehow manage to do it, we will still be emitting the same amount of CO2 in the atmosphere that we are doing today. Again, I'm talking about the climate change goal that the European Union has for 2050, which is having a net zero greenhouse gas emissions economy. So okay, as you can see, if the energy consumption continues to rise, this is virtually impossible. It's very hard just to offset the increase in energy consumption. I hope that you learned something in this video. Please correct something in my logic here in the calculations. If you think that, if you don't agree with something, please correct it. And bye for now.